Hello everybody, welcome to this week's Pat Problems with Helena and Kat. My name is Kat, I'm the Physics Access Officer for Oxford University, and this week I'm going to be taking you through question 5 from the 2015 Pat paper. A quick note before we start, which is that the 2024 Pat is going to be a multiple choice paper. This means that we're going to have the same balance of maths and physics questions. Syllabus is going to be the same, but at the end of all these questions, when you've done your working, you'll be selecting an answer at the end. Otherwise, no difference, so let's get started. So this question 5 asks me, for what values of m does this equation have no real solutions? Now, as soon as I see no real solutions, I'm thinking discriminant. And I know that the discriminant of a quadratic equation is less than 0 for no real solutions. So the first thing I'm going to do is rearrange this equation into the format of a quadratic. I'll start by rewriting the question, just because I always find if I miss that first line, I get a little bit confused. So 4x squared plus x minus 8 is equal to m, open brackets, 4x minus 3. The way I'm going to rearrange this is just by taking my right hand side over to my left hand side and then by grouping my x squareds, my x and my numerical terms. So that's going to give me 4x squared plus 8x minus 8 minus m, open brackets, 4x minus 3 is equal to 0 as a starting point. When I'm grouping together and I multiply this out, I'm going to get minus 4mx, which I can group together so that I get 4x squared plus, open brackets, 8 minus 4mx. And then from this term here, I'm going to get minus m times minus 3, which is positive 3m, so plus 3m minus 8 equal to 0. Now that I'm in the form of a quadratic, I've got my a, my coefficient in front of the x squared, my b, my coefficient in front of x, and my c, my standalone numerical term, 3m minus 8. I know that for no real roots, I want my discriminant to be less than 0. My discriminant is b squared minus 4ac. Some people use a capital D. I always write the whole thing out, completely personal preference, especially in multiple choice where we're not going to be seeing your working. So whatever makes it easiest for you to have a clear idea of what you're doing. My b squared minus 4ac, if I put everything out nice and clearly so you can see as I work, and have 8 minus 4m all squared minus 4 times 4 times 3m minus 8. You could at this point take some common factors out of this to make it multiply out a little bit easier, but personally I don't find 4s and 8s particularly hard to work with, so I'm just going to run with it. So when I multiply this out, I get 64 minus 64m plus 16m squared. And then from this second section, I have minus 48m plus 128, always taking care with that double negative in the multiplication term at the end. Similarly to at the start, where I then had to group everything together in sensible terms, I'm forming a quadratic in terms of m. And when I tidy everything up, I get 16m squared minus 112m plus 192. Might not be immediately apparent to you, but they all have 16 as a common factor. So I can take 16 out and land with 16m squared, take away 7m plus 12. You can then use a factorising method of your choice to arrive at 16, m minus 3, m minus 4, and that is the term that I know has to be less than 0 in order for my equation to have no real roots. Really important here that you don't fall into the trap of setting this equal to 0 and coming out with m has to equal 3, m has to equal 4. We need to give this a little bit more thought, particularly because we're looking to arrive at a negative answer. Our key points are going to be 3 and 4, which would be where one of these brackets is equal to 0. But what we need to ensure that one and only one of these brackets is less than 0 at any given time. Otherwise, we would have two negatives, which would flip us, give us a positive solution, and two real roots. We also don't want them equal to 0, so our key points of 3 and 4 can't be solutions in and of themselves. And once you sort of work through that process, it becomes clear that m has to lie between 3 and 4 for the equation to have no real roots, which we can pop there. And hopefully you can imagine in the 2024 paper, you're then going to have a set of options very similar. You're going to have a good idea of what you're working towards. And that is question 5 from the 2015 PAT. Join us next week where we'll be taking you through another of the maths solutions. Thank you so much.